In the vast universe of data science, embarking on a project without proper scoping is akin to launching a spacecraft without a destination. Project scoping acts as the compass and the map, guiding data scientists towards a clearly defined objective. Imagine venturing into the cosmos with only a vague notion of exploration. You might stumble upon fascinating celestial objects, but without a clear mission, your findings lack context and purpose. Scoping requires a deep understanding of the problem at hand. It involves asking critical questions. What are we trying to achieve? What data do we need? What methods will be most effective? Just as astronomers meticulously plan their observations, data scientists must meticulously define the scope of their projects to ensure success. Once we have established a clear destination through project scoping, the next crucial step is to chart a course, a roadmap that outlines the path from our current understanding to the desired outcome. This roadmap provides a structured framework for the project, breaking down the complex journey into manageable stages. A data science roadmap typically begins with data collection and preparation, the bedrock upon which our models will be built. Next, we delve into exploratory data analysis, where we seek to uncover patterns, trends, and relationships within the data. With a refined understanding in hand, we move on to model selection and training, where we choose the most appropriate algorithms and techniques to build predictive or analytical models. Finally, we reach the model evaluation and deployment stage, where we rigorously assess the performance of our models and integrate them into real-world applications. This final step ensures that our models deliver tangible value and drive meaningful insights. Just as a spacecraft requires vast amounts of fuel to propel it through the cosmos, data science projects rely heavily on data to fuel their success. Anticipating data needs early in the project lifecycle is crucial, for without the right data, even the most sophisticated models are rendered ineffective. Consider the challenge of building a model to predict customer churn for a telecommunications company. To achieve accurate predictions, we need data on customer demographics, usage patterns, billing history, and potentially even social media sentiment. Failure to anticipate the need for such comprehensive data could severely limit the model's predictive power. It's essential to ask questions such as, what data points are most relevant to the problem? Where can we obtain this data? Is the data reliable and of sufficient quality? In some cases, we might need to collect new data through surveys, experiments, or sensors. By carefully considering data needs up front, we ensure that our models have the necessary fuel to thrive and avoid costly delays later in the project. Section 4. Transitioning to training breathing life into models. With a clear roadmap and the necessary data at our disposal, we transition to the heart of data science, model training. If we think of data as the raw material, then model training is the process by which we transform this raw material into valuable insights and predictions. Imagine teaching a child to ride a bicycle. We provide guidance, support, and feedback as they learn to balance, pedal, and steer. Similarly, during model training, we feed our algorithms with data, adjust parameters, and evaluate their performance, guiding them towards optimal accuracy and generalization. The choice of training algorithm depends largely on the nature of the problem and the type of data we are working with. Model training is an iterative process, often involving multiple rounds of experimentation and refinement. The goal is to find the sweet spot between model complexity and accuracy, ensuring that our models generalize well to unseen data. Section 5. A formula for success steps in model training. While the specific steps involved in model training can vary, there is a general formula for success that applies across most data science projects. The first step is to split our data into training and testing sets. This is crucial to avoid overfitting, a phenomenon where the model becomes too specialized to the training data and performs poorly on unseen data. We typically allocate a larger portion of the data to training and reserve a smaller portion for testing. Next, we feed the training data to our chosen algorithm, allowing it to learn the underlying patterns and relationships within the data. Once the model has been trained, we evaluate its performance on the held-out testing set. If the model's performance on the testing set is satisfactory, we can deploy it to make real-world predictions. Model training is not a one-time event but an ongoing process, allowing us to continuously improve our models and adapt to changing circumstances. Section 6. Real-world applications, models in action. The true power of data science lies in its ability to transform raw data into actionable insights and predictions that drive real-world impact. From personalized recommendations on streaming platforms to fraud detection in financial transactions, trained models are at the heart of countless applications that shape our daily lives. Consider the field of healthcare, where trained models are revolutionizing disease diagnosis and treatment. By analyzing medical images, patient records, and genetic information, algorithms can assist doctors in making faster and more accurate diagnoses. In the realm of finance, trained models play a crucial role in managing risk, detecting fraud, and optimizing investments. The rise of e-commerce has also been fueled by the power of trained models, enhancing our shopping experience and driving sales for businesses. These examples represent just a glimpse into the vast and ever-expanding landscape of real-world applications for trained models. Section 7. Significance and conclusion. The power of preparation. In the ever-evolving landscape of data science, the significance of meticulous project scoping and rigorous model training cannot be overstated. These two pillars form the bedrock upon which successful data science projects are built. Project scoping provides direction and clarity, ensuring that our efforts are focused and aligned with the desired outcome. Model training is the engine that powers our data-driven insights. Through careful selection of algorithms, meticulous data preparation, and iterative refinement, we transform models from mere lines of code into powerful tools. Just as a skilled architect wouldn't construct a skyscraper without a detailed blueprint, a data scientist cannot extract meaningful insights without meticulous scoping and rigorous training. These two pillars empower us to navigate the complexities of the data universe, transforming raw data into actionable insights that drive innovation and progress. As we venture further into the data-driven era, the ability to effectively scope projects and train models will become increasingly paramount.